So let's just start with the next presentation, which is, as Lucas already told, about checkJs. So what was my inspiration to do that talk? I saw this video of the build 2017, what's new in TypeScript. Did anyone of you see this video? Yeah, did you like it? Yeah, I also liked it a lot. It's from Anders Heilsberg, and he's the co-designer of TypeScript, and he brought in some enlightening facts. Other than that, I had a lot of discussions about TypeScript, like I have, especially with other developers. I have to write so much more code when using TypeScript, or I don't like to add those types, or it feels like writing Java. Who of you feels familiar hearing that code? Yeah, maybe a lot of you. And that is, as we all know, not completely true, because with type inference, TypeScript is taking a lot away of this responsibility. So the new type, it's getting better and better. In each version we have more type inference, and you have to write less of those examples. So as an example, this would be assumed as a number, and also return types are assumed. So if this is a number and this isn't a number, then also an addition of a number is a number. So TypeScript already knows this is a number. Now in this talk, Anders Heilsberg brought some quotes, and it's sometimes a bit hard to read because he was talking, and but I just quoted him how he said it. So he said, when we are checking TypeScript, we are basically, if you're unsure about something, we're gonna whine, and you will and give you an error and make you fix it. So we can be absolutely certain that we've checked everything, and that's maybe a bit the problem what a lot of people don't like about TypeScript, because they have to check everything, otherwise it could fail, right? And I think that's a bit the story or the background why this conflict is still around. And he also said the cool thing about TypeScript is that TypeScript is a superset of JavaScript. Is that JavaScript is just TypeScript with no type annotations, but that doesn't mean the checker can't check. It can check a lot, and this was the beginning how he led into a new feature. And what does that mean? So TypeScript is always following the development of ES6. So if they want to stay compatible, so they also have to do some compromises, and maybe sometimes that feels like pain for us. But that brought him to the point, what if we had a mode that is kind of the opposite, which is not that strict? And in fact, as we thought about this, we sort of realized that, hey, what if we had a type checking mode that was more of a conservative checking mode? So also the TypeScript team realized that, well, not all developers might like this feature or this behavior of TypeScript being that strict. And what means to have a conservative checking mode? He also explained that a bit like that. So if the compiler already knows for sure something is wrong, then why not letting you know? Because it's for sure not working. But if it could be true, and it's not certain that it's not true, then it's just great and everything goes on. So this is just a different approach. Instead of saying, yeah, everything is very strict, saying, hey, we try to see everything good until we really know it's not gonna work. And this is exactly what the checkJs compiler option is about. It was introduced in TypeScript 2.3, and it plays with some features. So what it basically says is that, or does, is that type checking can also be reported in JavaScript files. And how does that work? Since JavaScript TypeScript is a superset of JavaScript, every piece of JavaScript is also TypeScript, but without types. And since the type checker can check a lot, you can also assume certain things. And you have some features like nocheck, TS nocheck, which is here, to skip a line, or the TS ignore, as we already heard before in the talk of Lucas, which basically just ignores an error. And we also can play with the JSDoc support. So if there is some JSDoc information, like this annotation here, then the compiler can use this as an information about the type of the variable. And it can use all the informations of JSDoc, npm modules, and so on to help you checking your JS file, because the npm modules also contain type definitions, or might contain, because a lot of them already have them. So this could be used, right? So how does this check work? More or less it's just with the modern way how we write JavaScript with modules and classes, we can, or TypeScript can statically analyze the structure and give you these informations. But we heard it shouldn't be that strict, so to make it more easy, there are some relaxed rules, and I'll give you some examples. For example, object literals are by default open-ended. That means in TypeScript you would have an error if you would do something like this, and if you do it in JavaScript, this will not give you an error by default. But if you type it, you just give it the type of a structure, then it would give you an error. And this would be the error that is returned if you run the TSC, the TS compiler, and yes, compile it. Then another thing is also that parameters are optional by default. So as we know, in JavaScript this is allowed. You can use bar1 and you're just passing an A, and the B is then just undefined, which as we know can be dangerous, but it's still valid in with this check option. But if you have too many parameters, they know for sure something is going wrong and they will tell you about it. Another example is if you have an array and you define it like this, or in this example there is already used this annotation, then you would add a number, and you can also add a string, and this is kind of okay, because then the compiler just assumes, okay, this is now array with any, and this works. There are a lot more rules, but I don't want to go into deep into them. So how can we use this feature? So basically it's, as already was said, for legacy projects. If you have a legacy project, or you have an existing JavaScript project which is currently in development, but you want to just check out what TypeScript can find in the code. So you just add a tsconfig file, tsconfig.json, and you add an option, checkJs, and that's more or less it. The tsconfig.json file looks like that, with those two options. Checkjs can just be used combined with allow.js, and this wouldn't be necessary use, but in all the projects it was helping me because I could use the latest features. So now what I did was I just checked out some JavaScript libraries we are using often, and I tried to find out what's possible or what TypeScript would return or respond me to this project. And I'll try to do a live demo of this thing. So we use VS Code, and the project I'm first gonna show you is CSS-Comp. And CSS-Comp is a checker to check your CSS files, which is written as an npm module, and it basically orders your CSS file and also lints it. And I'm now switching to this folder. Can you read it, or is it too small? Maybe I can also make it a bit larger. Yes, maybe. Okay. So, and I stage all the files, so we are like in the beginning. And what I now have to do is this is because I have the file opened, sorry. Just close all the files. So, and I'm gonna stage everything. So, thank you. Okay, so before we start, we add a TypeScript tsconfig file. Just add a letter in it, JSON, and I prepared a little snippet so you don't have to wait for me to write it all. What is in there? It has these compiler options, and I added those two parameters, and yeah, the libs ES 2017 and DOM elements. So I could also remove those to start with, and we would already see in VS Code they already have a nice console report, so they would report me about these errors they found. And now the problem is that my tsconfig is not in the main folder, so I move it. Okay, and now there should be some more problems. So as we see, this is all the information that is returned by the TS compiler. You could also do it if by using TSC in the command line, and you would get the same. Well, then I have to add some types, because what we see now is that a lot of the errors are basically because I would head to npm install again. So now we have a lot of errors because require is not found, and this is basically due to the fact that I don't have installed the types of node. So I add them. Now it's too big. I hope you can read it. So, and some problems should be gone afterwards. So we already have just 15 problems, and this was also a bit the kind of the challenge to make it readable, because in the beginning I just had a lot of errors. And I also add another type definition, the TS JS doc. So this is the support that TypeScript knows about this doc comments I showed you before. And now we have still a lot of problems. So let's go and look into some of them. We have core.js, and yeah, I would still have to import some modules, but I don't want to go into that. But look what can be found. We have this lint function, and there we have an error. So this function has an error, and if I go over it, then I see that the problem is that the property context is missing. And now what we can do, because TypeScript found a type definition for that, can also go and look into it. We see there is no type definition, but there is annotation information. So the developers already used JSDoc, and which is quite nice. And yes, like this, you see there are just 2 parameters, and options contain of context, file name, and syntax. But in the case we had before, there was just syntax and file name, and that could be a problem, right? And what we now could do is to rewrite the doc because it was wrong. This could be optional, or we could also just add it as undefined, which would be maybe nicer, because yeah, we know we did that on purpose. And I can also show you another thing, plugin.js. So this is also kind of funny. Here there were a lot of setters, and they return something of the setter, and TypeScript says setters cannot return a value. So, well, fair. And then we have another one. Here we see that we have again 2 arguments, but only got 1. If we go here and see, okay, we expect file and options, but what we got was just options. File, sorry. And what we now can do is, for this example, I will show you how to make a parameter optional. If I add the, how is it called? Square brackets, then I don't have the error anymore. And I can also prove you that this is really causing the problem, because if I would, for example, expect an array, then it would complain again, I hope. Should complain. Maybe I was now in the wrong. What? Oh, maybe string is actually an array. Yeah, maybe. Maybe you can also expect the number. Ah, wow. Yes, you were right. So now it says a string is not assignable to the parameter of a number. So this is, I think this is quite impressive, because it can assist us a lot in making less errors in JavaScript, even using ES6, but you don't have the whole pain of defining everything. And I thought, or yeah, what is really cool in VS Code is that they took advantage of it, and they also made their auto-completion. I think I couldn't find the whole or the proof for that, but I think they took advantage of this new feature in TypeScript, and they can now provide you a lot more information about the code. So if you're interested, go and find out how this is actually working. But it has to do something with this automatic type acquisition, which more or less can take all the NPM modules and provide you types which are included in those modules. And this is very powerful. I prepared another example. If I just go back, and I would have an own project. This is just, it doesn't make sense, the code, but it was just an example. So it would, for example, tell me that I'm expecting here a string, but it's not. But I just defined numbers, and yes, this could work. And also in this example, I added a library. I added jQuery and the types of jQuery, and after this I can really use all the features of all the type definitions of TypeScript, or the typings of jQuery, sorry. And also, if I here have some errors, if I would use for example a number instead of a string, then it would give me an error. And like this, I just have much more security about security that my code is really working. So let's go to the to the take-home messages and my conclusion. As I already said, you can have a lot of benefits in modern JavaScript just by using this checkJs function. It will not cost you a lot, but give you a lot more safety. It could be useful to find bugs in your existing projects. And in TS files, the type checker knows even more. So write less code by using type inference, and really try to not write the types if you don't need them. These are my sources. You will find my I will publish these presentations if you want to go and check out the stuff. Further informations about this type checking in JavaScript files and so on. You can find it here in the first reference. And if you don't have any questions, then I'm finished. Thank you. Yeah. Yeah.
There was a switch, and the TypeScript-Compiler-Option taking that text is a string. So how do you know that the array is an array of numbers?
Because there are just numbers in the array. What is interesting, if I now would add a letter or a string, then it would use, but then I could still use a boolean, and it would tell me it's not a string or a number, and I could go play further, and at a certain point it would just be any. So it's really smart, yeah.